I'll try to explain briefly how we set up our logging infrastructure. It's targeted here for HPC, but it's a global infrastructure that we use for all our production servers. Quick overview, these will be the topics I'll be covering. I'll start with the short overview. The entire environment is built out of Docker containers that are running each of these components built on top of our production stack. The clusters put their data to the syslog environment, and then we start processing stuff and make it accessible for the users. The input looks something like this. Basically, it's the syslog output, some strange things you see or whatever that gets noted, and we as sysadmin or our application support teams can access the data through a web frontend called Kibana, and it basically reads stuff from the elasticsearch cluster. So how do we input the data? Everything is done through the syslog environment. In most situations, for some specific targets, we use custom logstash implementations on the machine. So if for some reason you generate a lot of data and you want send it through the entire syslog stack, you can push it directly to the infrastructure. Basically, we do this for all our audit logging. So on our interactive nodes, we have audit logging enabled, and we basically log everything, every command that's executed on the machine in every location of the machine. It generates log files that rotate every minute, so log files are 120 to 300 megabytes in size, so you can imagine the amount of data that gets generated. It's immediately injected into logstash to the cluster and injected into Elasticsearch. The normal procedure is read the syslog file, push it in the queue, and process it. That's the easy one. All data is exported through syslog, through a central syslog server. The setup is completely redundant. You can reboot, update, whatever. Everything fails over automatically, no loss of data, because our central syslog cluster has to be the one point that has all the data. The central syslog cluster is split up. It's not a single machine, it's also a separate cluster. So you have the syslog producer. Basically, all compute nodes, all production servers, Windows, Linux, whatever, injects data to the syslog gateway nodes. Those nodes are just a Linux kernel running with custom IP tables and inject the syslog data and parses and spreads it out over the storage nodes. So the storage nodes, there is a syslog daemon running. It listens on a port, filters, detects the host name, stores it on any location, on a specific location on the NetApp filer, and the NetApp cluster just makes sure that the data is redundantly stored. The log proc daemons, basically they are just Docker hosts. They are processes running on some Docker host, and they watch specific files on the cluster. So for instance, for HPC, we provide a soft link to all the latest log files of a specific environment. So you have the HPC latest folder that contains all the log files from the compute nodes from tier 2 infrastructure. And you watch all the files in that specific target. Logstash itself is freely available. It has several input types that you can use. Syslog, JSON, file. We mainly use syslog and file. Syslog if you inject directly syslog, but the one we are using is file access. The configuration file of the logstash looks something like this. I'm going to stand this. How you turn on the light? Okay. So this is the path that we specify. The logstash is running inside a Docker container, so there's no, the logstash daemon is not aware of all the other log files that are on the system. So only the HPC specific targets are mounted into the container, and they are accessible here. We tag them with a specific type, and this type will be used through the entire stack to identify on which log files we are using. The rest is just specifics for logstash, and you exclude the compressed files because at a certain point syslog rotates the log files, compresses all the stuff, moves it around and injects new files, and you don't want your file that you have already processed reprocessing again, so ignore the compressed files. Next one. Once the file is read, we output all the data to some other redundant system because, well, you want the chain to be redundant as well. If for some reason the RabbitMQ is not available, Logstash will stop injecting data. If RabbitMQ is available, it just takes the syslog message, puts it in an exchange here called HPC syslog. This is just the definition of the host that's running the RabbitMQ. You need to provide a key for RabbitMQ because that's how RabbitMQ works. The RabbitMQ that's running here is basically RabbitMQ for the entire log infrastructure. So you have one for HPC, you have one for the web interface, you have one for quick start. Well, we have a lot of RabbitMQ virtual hosts, and HPC is one of them. And if you look at the RabbitMQ infrastructure, you basically see something like this. Messages coming in, they go in the queue, the backend pulls them off, and they are gone. All messages inside the RabbitMQ still have the type syslog, HPC, and that's required for going on to the next step. So it's in the RabbitMQ, all queues are mirrored, so if data comes in, it's not act to the logstash, to this one, to the producer, before it is synced redundant to the disk. So if for some reason we restart the RabbitMQ while the message is not act, logstash will send it again. So there's no data loss there either. Oei. Yeah. Yeah, it's the ACK again here. The ACK is required, otherwise the message is not synced. Then you have the consumers, so we have Logstash again. These Logstash daemons are subscribing themselves to the RabbitMQ, and now they're subscribing to a queue. So in RabbitMQ you have exchanges and queues. Message come in to exchange, you give it a key, and the key routes it to a queue, and you can subscribe yourself to the queue. So these are subscribed to the syslog queue, here, HPC log syslog, and they are accessing this specific key. If you have other logs, so we have the audit logs, they come in directly, they come in from another Logstash daemon directly in the queue, they will have Logstash HPC's syslog audit. So just another way of separating all components of the environment. Until now, all data was still processed without changing it. So it was just read from syslog, put by Logstash in the RabbitMQ. RabbitMQ processes to the next Logstash, and now we do the specifics for the data. So if you want to manipulate it or add fields or index specific fields as a string or as an integer or whatever, you define it in this section. And this requires some more explanation. So we have a filter definition inside of logstash. Basically what you do here is, if the type, the one you've defined at the beginning of the, here you define, at injection time you define the type syslog. Now you can use that type to do the filtering. So in the end you can have one logstash processing all the log files, but we separated it a little bit more because, well, we have hundreds of things that we want to filter in the end, and you can have multiple logstash instances. If you start using it, you'll see that logstash itself can be very memory consuming, and it might be better to keep it small and effective than big and using a lot of memory. The message that's entered is from the type syslog, and you can do something with the message and separate the fields. So this one is an example of the message that is injected, and basically what we do here is you match the message. This is an example of the message, and you separate the first part. So you see here, these are templates that are available in logstash, and this field is assigned to these variables. So you have the syslog timestamp, hostname, syslog program, PID, and the message. Those are basically standard defined fields in logstash. Once you have selected those data into the messages, you can do the next step with the data. So here we detected that the syslog program here, the syslog program is, for example, module. We do on every module load, we post a message in syslog saying module load whatever has been done by this user. So we can do a specific filter based on the module. This now is a one for PBS, so every command that's executed through PBS also generates a log file. And here you do some specific filtering for PBS, saying you want to filter the job ID. Here it's here matching the job ID. You want to know the user. Here it's matching their data user, and the job name is their environment. So basically you can define which field you want to map to which variable, and then you can inject it into Elasticsearch. There are very handy debugging tools. This is one of the basics. You have to type a lot, but if you go to the herokuapp.com, there's also an interactive one where you just, basically it says, give me some syslog messages and I'll do some magic for you, and you can use this filter and here are your fields. So most of the times it works, but if you have some fancy stuff with a lot of characters or special characters in it, then it's not always doing what it's expected to do. But for the basic start, to get you started with the grok filters, you can certainly manage there. Then all your data is now known to logstash and is assigned to variables. Now we have to store it somewhere. So you store it in our Elasticsearch cluster. You can store it based on this type. So you have the syslog HPC type. You say okay, export it to Elasticsearch. You create a template for your data, and you put it in this Elasticsearch cluster. Yeah, I talked about this already. So the name and the filter is important for doing some stuff afterwards. What's important here is that each index is unique, and you can have your data pushed into multiple indexes. So if you say here if type is syslog HPC, you can have your Elasticsearch block, and you can have another Elasticsearch block putting it in another Elasticsearch cluster. So if you, for some reason a developer wants to have access to his data only, you can create a filter, create a tag, and add something here, export it to Elasticsearch or some other output source that's available. You don't need to synchronize your templates and your variables with other users. So you can have a specific definition for HPC, you can have one for your, let's call it HPC tier 1 environment, HPC tier 2 environment. In our use case, it's HPC, it's web environment, it's other environments. It's rather difficult to find something inside Elasticsearch itself. So you can query Elasticsearch, you get something out of it. There are plugins to view the data, but it's easier to use Kibana because it has some magic auto-discovery and shows you more nicer things. Other important things, if you forgot something during the creation of your filter, you'll have to inject your data again. So when you design your filters, you have to be very careful to think what fields you want to analyze and how you want to analyze them. If you want the field to be analyzed as a string, you have to define it as a string. If you want to have it analyzed as an integer, you have to analyze it as an integer. If you forget to put it in the template and you've injected your data for 3 months, you'll need to re-inject them again. Don't put all your data only in Elasticsearch. That's something that's I wouldn't suggest you to do. And filter your metrics as hard as possible or as deep as possible. So it's easier to combine the metrics afterwards in Elasticsearch or using Kibana. You can say easily filter me on user A and compute node B and processor type C. Elasticsearch will manage it, and Kibana also. If you create a combined metric of it, you can't filter on it afterwards. And every metric only has to be unique in its own index. So, for example, the audit log files or multi-line messages. So I'll show it in the demo in a second. It contains a lot of information. The syslog HPC log, it's just single line messages. So you can do whatever you want with it, however you feel. The metrics are always time-based, and it's easy to inject old data because you can manipulate during the process. So if you have a log file, it contains a timestamp, you can easily say, okay, this timestamp has to be used as the timestamp for searching the data. Your data is never overwritten, so there's no unique pointer to a syslog line inside your Elasticsearch. If you want your data to be refreshed, you have to remove everything and re-index it again. All by all, it's not that hard to re-index, but you have to think of clearing your data before re-indexing. Since we are in GMT +1, it's also not that great because data is stored over 2 indexes per day. So in the here, you see the data is stored into this index year, month, day, but it's basically on set 0 that is being stored, and the data from 11 o'clock till 12 o'clock in summer is stored in the day before, and well, you have to do some magic with Elasticsearch to remove those data. The re-indexing, well, you can start the logstash daemon that's just listening on a pipe, and then you can set cut your entire log file. It took 1 day to re-index 3 months, and we have 24 megabytes, 20 to 50 megabyte host log files of some 200 compute nodes. So, well, it's not taken that long. It puts some stress on your infrastructure. The storage is an Elasticsearch environment, again deployed on a Docker machines. All communication is done through the query node. So this part of the cluster is not known to the logstash infrastructure. We have some master nodes, some data nodes. Each data node has 3 terabytes of storage, and we have 12 data nodes. So data is stored in a triple copy. So for search performance and redundancy. And there are 6 Elasticsearch clusters on the physical nodes. So each Elasticsearch cluster has 3 terabytes, and basically it's some 2 terabyte, 2 socket machines with 256 gigabytes of memory, and Docker just manages the Elasticsearch environment. The frontend injects in the query, the backend also reads from the queries. It's important in Elasticsearch, there's no such thing as a retention policy. Data is pushed and you can keep on pushing, it never gets removed automatically, whatever. It goes in there, and as soon as your cluster by default is 85% full, it stops. Elasticsearch says, no can do. That's basically fail-safe, because in case you reboot one of your nodes, data gets resharded automatically to the other nodes, and that's the next gap is 95%. So the data, you won't lose any data if you lose some nodes. But now we have 4 months of data in it, and it's 2 terabytes of indexes, so you can store some years without problems. Viewing the data can easily be done with kibana. We provide the latest front end, because, well, users tend to want the nicest and coolest features that they've seen on Twitter, and so we had an old kibana setup, and then they would complain, we want a new, we saw we can use this, we saw we can use that. So we decided, okay, your front end will always be the latest version, but the impact is that we also have to keep up with Elasticsearch. So yesterday, no, the day before, I noticed, Elasticsearch, no, kibana has upgraded again, so I needed to upgrade Elasticsearch to the latest version. Well, it's not that much work, but it has to be done. So all the metrics are stored on a daily basis, and the last element is the date. There are fancy plugins for Elasticsearch to see the charts and the nodes and everything. And I'll go over to a demo. Try. You can see it here. That's not clear. Resolution is not high enough for this. So, I'll take the other screen as well. So basically, you can write any query you want here. So now I'll show you all the syslog messages from the SSH daemon, where the session is opened for a user. Yeah, not root because I was showing all, but for my specific user. And well, as it appears no session has been opened. Let's open a session. It automatically refreshes every some second, but let's refresh. Oh, voila. So one user, well, me, logged in, session opened for user. So it's easy to view this. This is just a simple example. Now let's see if I submit a job. And I want to know on which compute nodes this job is running. So I submitted an interactive job with 20 compute nodes. And I should have the job ID 348. So, refresh. You can see these compute nodes have been assigned to my job. I do want to use this. If I refresh again, you should see all compute nodes. 20 compute nodes are being used by this specific job. This is a basic visualization, so you can do diagrams, create a new one. You can see the options. So we have an array chart, data table, lines, metrics, pies, tile map, vertical, whatever. Enough options. Now, say you want to know which modules are being used. I've created a view for that. I'll open it here because the resolution is not high enough. So I'll take an overview of the last 30 days to see which modules are being used on our cluster. So the users are really liking R these days. So this is basically the graphs, or R is being used a lot. The timed run is also used. And another R. So this is the specific version, this is another one. So you can see easy over a specific time view which modules are being used on the system. You always have to be aware of the time constraint that you're using, because, well, you can have users who are really pushing a project and they need to finish it, so they will submit to the entire cluster. If you go over a period of 4 months or a year, it's more likely to give a good overview of the entire stack. But another thing is you can't really know what the users have put in their parsed. So yeah, you can check what they've put there, but anyway, users tend to put their modules that they are using a lot into their parsed. So if they do something like, we have a worker framework where they can submit jobs that run less than 30 minutes, and they can submit, say, a job of 3 days that run jobs that run less than 30 minutes, and the user interface or the modules gets reloaded on every run, so then your metrics are a bit off. But well, in the last 90 days, R was very popular. You can use this for any kind of metrics or information that you want. These logs are from the syslog, but you can also check your audit logs. For example, well, this isn't going to work. It's okay. I have to reduce this time frame to last 10 days. Sometimes you notice that there's something wrong with your system, but you can't really pinpoint what's going on. Let's see if I still have it. No. Well, this is basically a performance killer. Some user is running touch on a very active base, and then it's very easy to detect who is running this if you have the right filters in place. So we do it for some stuff ourselves. So yeah, this is the root that's doing touch, but there are also users that manage to do 350,000 instances of touch in 30 seconds. So you can easily detect those anomalies with the elasticsearch. That's about it for the demo, I think. So there's no more in the presentation. So any questions?
Thank you, Joe.